In this class, we will be looking at the concept motion under gravity in a vertical line. So what exactly is this concept all about? So you can see from the words motion under gravity, what does it mean? It means that gravity plays a key role in the motion of an object. So let's take an example here. If I take a ball and I throw it up, what happens? You can see the ball just comes back to the position from where I have thrown it. So what is that? Why is the ball coming back to the position from where I have thrown it up? Because the ball is coming back to my hand under the influence of gravity, where the gravity always pulls any object towards itself, towards the center of the earth. So motion under gravity in a vertical line. So you can observe when I throw a ball up, what happens? The ball follows a straight path and comes down in the straight path if it is not disturbed by any air or any other external disturbance. So this is the basic concept, that motion under gravity in a vertical line. Before I get into the discussion, let me revise the formulas of equations of motion that we have discussed in our previous class. So you can see I have used the notations V bar is equal to V naught plus A bar T. You can clearly observe, why am I writing bar above V bar, V naught bar, A bar? Because they are vector quantity. And here you can see x bar minus x naught bar is equal to V naught bar T plus half A bar T square. And the third equation goes like this: V square minus V naught square is equal to 2A bar x bar minus x naught bar. Here x bar is the displacement, V is the velocity, V naught is the initial velocity. This is the notation that I used for deriving the equations of motion. However, the notations that we use in textbooks and that is used commonly in all the textbook is V bar is equal to U plus AT, because this is the standard notation. It has been used in many of the textbooks. So it's quite similar to the same equation here. Here instead of final velocity I write V bar. You can see final velocity is V bar. U bar indicates initial velocity, A bar indicates acceleration, S bar indicates displacement, and T indicates the time taken by the object to move from one point to the other point. These are the basic equations. Anyway, I want to point out one important point here. You can see here the equation says x bar minus x naught bar, but you don't see any s bar minus s naught bar, because here while deriving the equation I have specifically said that there was some displacement at t is equal to 0 position or the initial position. But in this case we generally take, when t is equal to 0, we take that s bar is s naught bar is equal to 0 meters. That is, there is no displacement at t is equal to 0 seconds. Now let me get back to the discussion of motion under gravity in a vertical line. So these are the standard sign conventions that we use for solving problems related to motion under gravity in a vertical line. To explain these sign conventions, I will use an example here. I will discuss it with the help of an example. Let me draw the example here. Let me draw the diagram to explain it. So here I have a platform, or you can take it as a wall. It's a raised platform. It's a raised platform. Let the height of this platform be h. Let the height of this platform, raised platform, be h. And I have three persons. This is person 1 standing here, person 2 standing here, and person 3 standing on the wall. And there is one more person standing here near the bottom of the wall. This is person 1, person 2, person 3, person 4. Now each of these persons have a ball in their hand. Let me take the ball to be, a ball is there in their hand. A ball is there in their hand. Now what these people are going to do is, even this person is also having a ball with him. Now these persons are going to throw this ball from the wall in different ways. So let's take the person 1 throws the ball straight upwards and it falls down here. He throws the ball upwards with a velocity. Let's take the velocity with which the person 1 throw upwards is u1 is equal to u meters per second. Okay, so what is u1? It is the velocity with which the person 1 throw the ball upwards. Now let's take the person 2. The person 2 is not going to throw the ball, he is just going to drop the ball. That is, he is not going to throw the ball upwards or downwards, he just drops it. Means the initial velocity of the ball when he is dropping is 0 meters per second. That is, he throws the ball in this way. He just drops the ball, it reaches here. So what is it? U is equal to 0 meters per second. So the velocity of the ball when he is dropping it, means he is not applying any force on the ball to give some initial velocity. So the velocity is U is equal to 0 meters per second. Now let's take the third person. He, instead of throwing it upwards with velocity, he just throws it downwards with a velocity U. Let me write that. So he throws the ball. Let's take this U3 is equal to U meters per second. Here U2 is what? U2 is 0 meters per second. Now what about the fourth person? The fourth person who is standing at the bottom of the ball throws upwards with a velocity U. Let me take that. So he is going to throw the ball and it falls here. Let's take, he throws with a velocity U4 is equal to U meters per second. Now you have four cases. Case 1, what is the case 1? He is throwing a ball with a velocity U is equal to U meters per second. That second case, he is throwing a ball, U is equal to 0 meters per second. That is, he is not throwing, he is just dropping the ball. The third case, he is throwing the ball downwards with a velocity U is equal to U meters per second, and the person who is standing at the bottom of the wall is throwing a velocity with a U is equal to U meters per second. So these are the four cases. Now what I am going to do is, I will take one equation from our equations of motion and I apply it to each case by applying this sign conventions in it. That is, I take a equation, I apply to this case by giving these sign conventions to it. Let's see that case 1. How does the formula behave when I apply to case 1 by applying the sign conventions? Let's see the sign conventions. What does it say? It says that the displacement is taken as positive for final position above the initial position and negative if it is below the initial position. What does it mean? Let's see what does it exactly mean. So since we are taking displacement and velocity, we can apply XY coordinate system to it for better understanding. So what we generally do is, to analyze such type of cases for any problem, we generally correlate or we see these motions through the lens of XY coordinate system. So let me draw an XY coordinate system to help us analyze these cases much better. So I am going to take the two cases, XY coordinate systems, and I apply here. So let's take this case to be minus y, this is plus 5. Let's take another case here. It is something like this. This is plus x and this is minus x. What am I doing? I am actually, and let's take this is 0 position. It's a origin. So what I am trying to do, I am trying to observe these motions through the XY coordinate system, where it will help me to apply the sign conventions clearly to the different scenarios while applying this to this equation. So let's see. So what is the first equation? Displacement is taken as positive for final position. So what is the final position in this case? You can see, if I am taking this as the initial position, it is at the 0 origin. So as we know, anything that goes below the 0 is minus y-axis, and anything that go above the 0 is plus y-axis. So you can clearly observe what is happening to the ball as it goes down. It is actually going in a negative direction. You can clearly see displacement is taken as positive for final position above the initial position, but here the final position is in the negative region. That is, when you apply this formula to this case, as per the sign convention, how the equation will look like. Let's see. So you can see S bar is the displacement. How much displacement did the ball travel as it goes up, it comes down, and what is the displacement? The height of the wall is minus h. Why am I writing minus h? Because initial position is at 0 and the final position is minus h. So I write it as minus h is equal to, now observe the initial velocity. initial velocity is taken as positive when it is in the upward direction. So you can see, while this person is throwing the ball upwards, in what direction is the person throwing the ball upwards? It is actually going in the positive direction. So we write plus u t is the time taken by the ball to reach the final position. Now coming to this a, what is A? A is acceleration due to gravity. As we have already discussed, our motions are under the influence of gravity. We always take acceleration as minus g, because minus g always acts in the downward direction. Whenever we take an xy coordinate, the negative region lies in the downward direction. So we write minus half g t square. Why this minus? Because it is due to minus g. Now let's see the second equation, means second case. If I apply this equation to second case, what happens? Here this person is just dropping the ball. Now you can clearly see u is 0 meters per second. When he drops the ball, what is the final position of the ball? The final position of the ball is minus h again. Why is it minus h? Because we are taking the initial position to be origin and it is coming down with a displacement minus h. Then we write, what is u? U is, he is dropping the ball. So it is 0 into t minus half gt square. Why minus half gt square? Because minus is due to the acceleration which is in the minus g direction. So again minus half gt square. Now let's see what happened when we apply to the third case. Third case, what is he doing? He is trying to throw the ball with a velocity u3 is equal to minus u meters per second. Why minus? Because he is throwing it downwards, minus u. So we write it as, again, what is the displacement traveled by the ball when it from the initial position to the downward direction? It is going in the negative axis. So minus h is equal to minus ut minus, why minus? Because a is minus g, minus half gt square. Now let's see the fourth case. It's very important. Where is this person standing? As per our xy coordinate system, he is standing in the negative axis. He is standing at the bottom of the ball, which is considered to be the negative axis. Now let's see what is the displacement of the ball that is thrown upwards by the fourth person. You can see the ball goes up and comes back down. So where is it coming down? It is coming to the same position where this person have thrown the ball. So the displacement of the ball is 0, because whenever a ball on an object goes and comes back to the same position, or there is no change between the initial displacement and the final displacement, then we call the displacement is 0. That is, in the fourth case, what happens? The displacement is, it is going upwards and coming back downwards to the same position from where the person have thrown the ball upwards. So it is 0 is equal to, what is u in this case? U is, he is throwing the velocity in upward or downward direction. Here the u is positive. U is positive because though he is standing in the negative axis as per our observation, he is throwing the ball with a u meters per second which is in the positive direction. He is throwing upwards. So we write ut. Now what is g? As we know clearly, minus g, because acceleration is always acting downwards. Minus half gt square. Now you can clearly visualize how the formula is applied to each case by using the sign convention. These are the sign conventions which I am applying to all the four cases. Now let's see the points that we must remember while solving these problems. Let us see the points that we must remember while solving the problems related to motion under gravity in a vertical line. Anyway, I have written the equations of motion. Now let's see the points that we must remember. So the first point says the motion is independent of the mass of the body. What is that exactly? To do that, I'll explain this with the help of a practical case where I have a ground. I'm taking a ball here. This ball is thrown upwards with a velocity u, let us take. It travels, the ball travels upwards, it just travels upwards and it reaches a point, final point, a topmost point. Let's take the height traveled or the displacement of the ball from the ground position to the topmost position is h. Now let's see, the ball reaches here, and what happens? What would be the velocity of the ball when it reaches the topmost position? It is v is equal to 0, and the ball starts descending, and finally it touches the ground from where the point of projection is. So this is the case that I am going to take into consideration. So this is velocity, and it goes upwards, it reaches the point, topmost point, it comes down and falls back to the same position from where it was thrown. So this is the case where this is u is equal to, the initial velocity is u meters per second. Now let's see what exactly says that. The motion is independent of the mass of the body. To do that, let us calculate the different parameters of this. Now I am going to take, now let me calculate the time of flight and the velocity u, using the terms that we have. So let me substitute these values in this first equation. So doing that, what happens? Now you can see v is what? The final velocity v is 0, and u is, as you can see, it is u. Then what is a? As you can clearly see, a is always acting downwards, it's minus g. So when you substitute these parameters here, these values into this equation, you get minus gt. Now this can be reframed as minus u is equal to, then we get minus gt. So t is u by g. This is what we have got now, t is equal to u by g. Now let me calculate the velocity in terms of these g, h, all those parameters. Now what I am doing, let me substitute this value into this equation. So we have v square minus u square is equal to 2as. Now let's see, what is the final velocity here? It is 0 square minus u square is equal to, what is a? A is minus g. So you get minus 2g. What is h? What is the height of the maximum, means height of the maximum point, or the height of the topmost point in this particular case? It is s. S is the displacement, and we take it as h. I am taking it as plus h because it is going straight upwards. It's in the positive direction. So what happens? Let's see. U square is equal to 2gh. This can be written as u is equal to root of 2gh. So what I want to tell you is that t is what? T is u by g. It's actually time of ascent. Now what would be the time of total time, or time of flight? Means time taken by the ball to start from the initial point and go to the topmost point and come back to the initial point or the starting point. So time of flight would be ta. Time of ascent, you can see I have calculated it to be u by g. So total time is equal to ta plus td is equal to 2u by g. Now we should clearly see the second point. It says time of ascent is equal to time of descent without air. Means this case is valid only when I am not taking air friction into consideration. If I take air friction into consideration, it's a different case. So let me draw the air friction and explain what happens if I take air into consideration. So here the example that I have taken, it is a normal case where it is vacuum, means there is no air, means there is no resistance of air. So let me take the air resistance. So generally when you are moving or traveling in a car, you can see the air will be opposing the motion. Means whenever you travel, you can see either you travel upwards or downwards, or when you go upwards, when you jump, you can see air always opposes your motion. When you are coming down, air opposes your motion. So air has a tendency to oppose the direction of motion. So when the ball is going upwards, in what way the air will be opposing? Air will be acting in this direction, means opposing. Air friction is, means I am writing A, air friction, means air will be opposing the motion of object. Similarly, when the ball is coming down, what happens? It will be opposing. Air will be in this direction. So you can clearly see while the ball is going upwards, what are the different forces acting on it? Means you can see minus g is pushing it downwards, air is pushing it downwards, because air always opposes the direction of motion. So what would be the time of ascent? So you can clearly see time of ascent by using this case, A and both are acting, means air is pushing down and gravitational force is pushing down the ball. So the time of ascent in this case with air would be Time of ascent in this case, like we can take time of ascent here, it would be TA is equal to U by G plus A. Why am I writing G plus A? Because you can see when it is going upwards, both are acting downwards. Now let me take TD. TD is equal to what happens? You can see air is opposing, like the ball goes here, it comes down. What happens? Gravitation as usual, it is pushing the ball downwards. But air is opposing because air opposes the direction of motion. When the ball is falling, air opposes in this direction. So TD becomes UG minus A. Now you can clearly see when you have a denominator high value, what happens? TA decreases. That is what exactly happening here. Time of ascent is less than time of descent with air. When we take air into consideration, what happens? It is time of ascent is less than time of descent. Now let's see the third point here. The speed of object at projection is equal to speed at which it comes back to the point of projection. In a general case, when we don't take air into consideration, the velocity of projection is equal to the velocity with which it hits the ground. That is, means u initial projection is equal to root 2 GH, but when it comes down, it is same root 2 GH when we don't take air friction into consideration without air. But what happens if you take air, or the practical case where we have air friction prevailing in our atmosphere? So when we throw a ball up, what happens? You can see air opposes it. So same case applies here. Now the formula turns out to be something like this. Now in this case, U initial, while it is moving towards top to top, bottom to top. When it is moving from bottom to top, the equation becomes 2, what is it? G plus A H. This is while it is moving from bottom to top, and U top to bottom would be root of 2 G minus A H. See, the G minus A is, they are opposing, they both are opposing. Here both are supporting, means the ball is pushed down by gravity as well as air. So these are the 4 cases that we have to keep in our mind while solving the problems.